Good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today I am going to discuss a topic in discrete mathematics with probability and hypothesis testing, and my topic is test of hypothesis, small sample test. There are different types of tests. Here I am going to explain the t-test. So the first one is we have to define the t-test, and I am going to give the formula for t-test. The t-test is otherwise known as a student t-test. T-test is a statistical test. It is used to determine whether the test is significant difference between a sample mean and a population mean. We are going to check whether the difference between the population mean and the sample mean, if it has some differences, then we can define two types of an hypothesis. Okay, first hypothesis is null hypothesis, and second one is alternate hypothesis. If it has a significant difference, then we can go with an null hypothesis. If it does not have some significance, then we can go with an alternate hypothesis. Okay, for testing this hypothesis, we are having a formula called student t-test, otherwise an t-test. So the formula is x bar minus mu divided by s by root n. Here x bar is nothing but the sample mean, mu is nothing but the population mean, s is the standard deviation, and n is the number of samples. Okay, the denominator will give you the standard error of the mean. Second one is degrees of freedom. Degrees of freedom for the particular problem can be calculated by using a number of sample minus 1, that is df is equal to n minus 1. Conclusion, the calculated t value will be compared to the distribution table. If it is less than or equal, then we can tell that the null hypothesis is accepted. If it is not greater or something, then we can go with an alternate hypothesis. Okay. The properties of student t distribution is, student t distribution was introduced by William Seeley Gosset, has the following important properties. The first property is bell shaped and symmetrical. If we draw a distribution diagram for the particular problem, the diagram will be is in the form of a bell shaped, that is in a symmetrical shape. The mean value of a t distribution, if we calculated the arithmetic mean of a t distribution, then the value of that distribution will be 0. Based on the degrees of freedom, the shape of the shape will be changed according to the degrees of freedom. If it has a smaller degrees of freedom, then we can spread heavier tails. If it is larger df, then it is closer to the normal distribution. Heavier tails than normal distribution. When compared to the standard normal distribution, the t distribution has a thicker tails. Okay. Total areas under the curve 1. The total probability under the curve should be equal to 1. Next, testing of hypothesis. A testing of hypothesis has two means. If suppose we have two different means, then we can have a separate formula. T is equal to x1 bar minus x2 bar divided by sb square root of 1 by root n plus 1 by n2. Okay, where sp is equal to square root of n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. Whereas here the degrees of freedom is the denominator of a pooled variance, that is sp, pooled standard deviation. So the n1 plus n2 minus 2 is the degrees of freedom for this kind of a problem. For independent sample, t is equal to x1 bar minus x2 bar divided by s1 square divided by n1, s2 square divided by n2, whole root of. This is otherwise it is called as a Wells approximation. Sometimes in our problem they will ask to find a Wells approximation value. For that cases we can use this formula to calculate that value. Paired t-test. T is equal to d by sd by root n. Sd is nothing but the standard deviation of the differences of two means. If suppose they have given a two different set of values, we can calculate the two set of means, that is x1 bar and x2 bars. For that we can also find two different set of standard deviation also. This kind of problem will have a degrees of freedom as n minus 1. Second one is Welch-Satterthwaite approximation formulas. Welch-Satterthwaite approximation formula is already given, but for unequal variances, sometimes the variance is also unequal based on the mean values. For that kind of problem, we can solve by using a formula df is equal to s1 square by n1 plus s2 square by n2 the whole square divided by s1 square by n1 the whole square divided by n1 minus 1 plus s2 square by n2 the whole square divided by n2 minus 1. Here s1 s2 square are the sample variance, n1 n2 be the sample sizes. This formula provides an usually a non-integer value to find the degrees of freedom in the unequal variance. Last one, the major one, that is the sample differences in the population mean and the sample mean. To test this differences, we have two kind of hypothesis. One is null hypothesis and another one is alternate hypothesis. If the population mean equal to the sample mean, then we can go with an h naught equal to mu equal to mu naught. Otherwise, if it is less or greater or not equal, then we can go with an alternate hypothesis. The alternate hypothesis is calculated by using the same formula only, but we can come with an conclusion by using the level of significance. Here the level of significance differs to problem. Here the level of significance is 0.05 or 0.01. Sometimes if the hypothesis is of 1%, sometimes the level of significance is 5%. From that case, we can compute the test value by using the formula t is equal to x bar minus mu naught divided by s by root n. So x bar is the sample mean, mu naught is the hypothesis population mean, sample standard deviation, n is the sample size. These are the basic formulas and the basic concept needed for going with an hypothesis test using a small sample test using a t-test formula. These are the basic which we have to learn first, then only we can go with the problem. So this basic will help you to solve the hypothesis problem. Then we can see the problems using the hypothesis test in our next videos. Thank you.